I just made an explainer video to just give you a quick rundown of distance, velocity, and acceleration in calculus, because this is not a physics class. We're using physics to apply calculus to learn calculus. But I just want to reiterate, in case you're crazy enough not to go to the explainer video and maybe give me a little comment so that I know you're engaged. Here's what we need to remember. Distance doesn't come from nothing. You don't teleport places. And speed doesn't come from anything. You don't just magically go 60 miles an hour. Acceleration creates velocity, and velocity creates distance. And that is to say that the derivative of distance is velocity, and the derivative of velocity is acceleration. And if you think about it very quickly, maybe you know that distance is measured in something like miles. Well, velocity is measured in miles per hour, because you're taking the derivative of distance with respect to time, and that's dividing by time. That's how you get a velocity. Well, acceleration is in miles per hour squared, because it's the derivative of velocity. So you're dividing by time again. You see kind of how this goes? Now, that's all you need to accomplish this for now, okay? And here's what I'm going to do for you. I'm going to remove this because we don't need to go over the fancy calculus. We're just going to do some problem solving, and we're going to learn it through practice. But notice they're going to give us an equation here. I'll read it real quick. The height of a projectile shot vertically upward from a 2-meter point. So we have a cliff. It's like a 2-meter point. And we have a velocity that it gives us, and it's going to go like this. Right? You ever thrown something off a hill? It's going to go up, and then it's going to come down. But I want you to notice this equation is all about h, the height, which means we don't really care about the left and right part. We only care about the up and down part. It doesn't matter to us if it looks like this or if it looks like this. We're measuring height versus t for time. Okay, height and time. So don't think about this in 4 dimensions. Just think about this as height and time. We're going to take the derivative of that because height is a distance, right? And all physics has to be unit friendly, which means distance equals distance. And that means everything in here has a unit of distance. If this is miles, this is miles, this is miles. And it might not look like that, but let's just think about this for a quick second before we solve these. You have a starting height of 2 meters. That's this. They tell us right here. And then you have a velocity of 24.5 miles per hour, or whatever it might be, times t for time. That's in hours, and you again end up with miles, or meters, whatever you want to call. For your distance, it's a unit of distance. We don't care about it. And big shocker, negative 4.9 t squared is your acceleration, because you're going to have an acceleration measured in, let's say, meters per second squared times time squared. That's seconds squared, and you end up with meters. So distance is always measured in terms of distance. I know that's crazy, but maybe it needs to be highlighted sometimes. So the formula they give us is h equals 2 plus 24.5t minus 4.9t squared. Now, what does that tell us? We have one factor of our starting height, we have one factor that's our starting velocity, and we have one factor that includes our acceleration. And when we write the variables for this, this is called, well, we'll call it h naught, the starting height, and we'll call this v naught, the starting velocity, but we're just going to call this a for acceleration. And the reason it's only a and not a naught is it's never going to change. This is gravity's effect right here. And it's negative 4.9 because gravity's always pushing down like this. Always pushing down. Wherever the ball is, gravity's pushing down. Now you may throw it upward to start, but what's going to happen? It's going to start getting, it's going to start reversing direction because gravity wins. Eventually. Not right away, otherwise things would never leave the ground, but gravity will win. So let's look at what they want. Part A says find the velocity after 2 seconds. Well, what do we have here? We have a distance. So velocity is the creator of distance. It is the derivative of distance. So let's take a derivative. What's h prime? That's going to be our velocity. And that's equal to 0 plus 24 point, looks funny with that, 24.5 minus 9.8 t. Yeah? So our velocity is equal to negative 9.8 t plus 24.5. That's it, right? We found our velocity equation. We just took a derivative with a power rule. And they want to know what it is after 2 seconds. We'll put in 2 for t. 9.8 times 2 is what? Let's type it into the little calculator machine here. That's 19.6. You add 24.5, and I get, sorry, you need the negative, right? So 9.8 times 2 is negative 19.6, and then plus 24.5, you're going to end up with 4.9. Did I get that right? It doesn't feel right, but I'm going to double check here. That's what I got, is 4.9 meters per second. So just like that, with a basic equation, we already know the velocity after 2 seconds. And if you plug in 4, you're going to get the answer for 4. Do you need me to do that for you? I'm hoping not. I think you can put 4 into a basic linear equation here. Now it says, when does a projectile reach its maximum height? Now we have something interesting. I'm going to move this out of the way. Let's take this 2 away too so it doesn't cloud us up. And we'll put this velocity right up underneath the height here since we've already worked out the derivative. And I'll fill in the rest real quick to make it cute. And we'll move forward. All right. What is the maximum height? Well, this is a parabola, isn't it? We know you're going to throw it in the air. It starts from a certain height, but we don't need to worry about that right now. It starts from a certain point, and then it's going to hit the ground. Well, what's the highest point look like? Right here. What's the slope of this height? It's exactly 0. Because as we found in other lessons, the maximum height or the minimum depth or bottom is at a slope of 0. Which means all I need to do is find when velocity is 0. You know, first you throw it up and then eventually it's traveling down. At the highest point is when it's not. That's when it has an infinitesimally small moment of non-movement right at the top. So I'm going to set my velocity to 0, and that is what the height will be. So I add this over, and I'm going to get 9.8 t equals 24.5. Divide by 9.8, and it looks like it's going to be about 2.5. Yeah, it's 2.5. So after 2.5 seconds on this trajectory, I'm at the top with this right here. T equals 2.5. Now, that was easy. They say now, when does it hit the ground? Well, hitting the ground that's a distance. That's a height of 0. So I'm just going to take this original equation right here and apply the quadratic formula to it. Do you remember the quadratic formula? You better plug it in. But it's literally like 0 equals. And if you want to write it in the right order, I don't know why the problem doesn't, but you should always write it in power order like this. Apply the quadratic formula to this and you're going to get some time value. And it's not just going to be double this. Sometimes it is, but because you start at this height of 2, it's going to be funny. And just plug this into your quadratic formula and you will get the correct time for that. That's all you have to do to know when it hits the ground. And notice that it says, what is the maximum height and when does the projectile reach its maximum height? So we did not calculate the maximum height. We calculated when it reaches that height. So we just need to plug 2.5 into these. 2.5 squared is 6.25 times 4.9. So this becomes, I'll write it in like red, negative 30.625. And let's plug in 2.5 for the velocity factor, which is 60.2 2.5, and then we have a 2 here. So let's put them together. And you're going to get 32.625. That's the maximum height here. I'm just going to write 32 because you should get what I'm saying here. Okay. And lastly, it says, what's the velocity when it hits the ground? Well, we need to solve for time on that. And I did not do the quadratic equation, but I'm going to say somewhere around 5.5 seconds, right? It's going to be somewhere around that. 2.5, probably, let's call it just 5 seconds, just to keep it easy. All you need to do to get the correct answer for that is take this velocity equation you found with a basic power rule and plug in t. So you do like negative 9.8 times whatever time it was, let's say 5 seconds, plus 24.5. And in this case, you know, it's going to be like negative 20-ish. I am not exactly solving this because that is not the point of solving this problem. I'm using it as an example to show you how to walk through it. If your velocity is negative, that means that the projectile is traveling downward. And when it hits the ground, it better be pointed down or you've made a mistake. So use this as like a template for the next 10 problems where I will work out the actual numbers for you and we will come to conclusions together.